Morning students of class 12th. Today in the topic of magnetism, we are going to learn about Lorentz force. First step in the chapter of magnetism was to calculate different magnetic fields. Which laws we have used to find the magnetic fields? Number one is Biot-Savart's law and number two was Ampere's circuital's law. Okay, now it's time to calculate the force. The force acting on a charged particle which is moving in a magnetic field. Okay, so how do we find this magnetic force? It is known as the Lorentz magnetic force or simply the Lorentz force. Okay, how do we find this force acting on an electric charge which is moving in the magnetic field? So here we have the equation. You can see F is equals to Q into V cross B. What is Q? Q is the charge on which the force is applied. What is V? V is the velocity of the charge with which it is moving. And what is vector B? Vector B is the magnetic field in which the charge is moving. Okay. So F is equals to, or vector F is equals to Q into V cross B. This is Lorentz force equation. I can simply write it in scalar form also, and in scalar form we just multiply this V cross B and make it VB sin theta. Okay, so F is equals to QVB sin theta. Again, what are the variables of this? F is force, Q is the charge on which the force is applied, V is the speed with which the charge is moving, B is the magnetic field in which the charge is moving, and sin theta. Theta is what? Theta will be the angle between V and B. Okay, theta is the angle between the velocity vector and the direction of magnetic field. Okay, so in this Lorentz force equation, let us find out two things, that when is this force minimum and when is this force maximum. Looking at the equation, see, again F is equals to QVB sin theta. Now what if the value of theta is equals to 0, or what if the value of theta is equals to 180? Theta 0 means the angle between velocity and magnetic field is 0 degrees. That means both of them are moving in the same direction. Okay. And if theta equals to 180, that means the direction of velocity and direction of magnetic field are mutually opposite. In the diagram you can see Q1 is moving with velocity V in the direction of magnetic field B, and Q2 is moving with the velocity V opposite to the direction of the magnetic field. So for charge Q1, theta will be equal to 0, and for charge Q2, theta will be equal to 180. Now the mathematics of this. See, if theta equals to 0 or 180, then what is value of sine 0? It will be 0. What is the value of sine 180? Sine 180 is again 0. So if sine theta becomes 0, what is the force? The force is again 0. That means this is the minimum value of force. Alright. So if force is 0, that means what will happen to charge Q1 and Q2? If the force is 0, that means the acceleration of these charges will also be 0. And if acceleration is 0, that means there is no change in the speed, there is no change in the direction also. What is acceleration? Acceleration is speed plus direction. And when I say that acceleration is 0, that means there is no change in the speed of particle, there is no change in the direction of particle. So what will happen? What is the fate of these charges Q1 and Q2? They will keep on moving with the same velocity in the same direction. ठीक है, तो क्या इफेक्ट करता है? कुछ भी इफेक्ट नहीं होता. If the angle is 0 or 180, how is the charge Q1 and Q2 affected? They are not affected at all because there is no force acting on them at all. Okay. Now let us go for one more example. Say this thing. If the velocity of the particle is 0. That means the charged particle is at rest. In the diagram, just take a look at this Q3. What is Q3? It is a point charge. What is the velocity of that point charge? The velocity is 0. The charged particle is at rest. Now, if it is at rest, velocity becomes 0. If velocity becomes 0, what happens to the force? Force also becomes 0. Okay, now what does this mean? This means that if a charged particle is moving or is not moving, it is at rest inside a magnetic field, there is no force acting on that charged particle. Okay, देखो अगर किसी चार्ज को आप इलेक्ट्रिक फील्ड के अंदर सिर्फ रख देते हो, स्टेशनरी करके रख देते हो, जीरो वेलोसिटी पे रख देते हो, तो क्या होगा? उस पर फोर्स लगेगा. यस, इट विल एक्सपीरियंस अ फोर्स इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. और क्या होगा? फोर्स लगेगा तो उसका एक्सेलरेशन होगा. किसमें? इलेक्ट्रिक फील्ड के अंदर. बट हियर वी आर नॉट हैविंग इलेक्ट्रिक फील्ड, हियर वी आर हैविंग मैग्नेटिक फील्ड. ओके, व्हाट इज द फोर्स? फोर्स इज इक्वल्स टू 0. तो इस चार्ज पार्टिकल Q3 का क्या होगा? इट चार्ज पार्टिकल Q3 विल रिमेन एट रेस्ट ओनली बिकॉज द फोर्स इज 0. फोर्स 0 है, मतलब वो अपनी जो प्रेजेंट स्टेट है उसी को कंटिन्यू करके चलेगा. गॉट इट? सो इन दिस केस ऑल्सो द फोर्स इज 0. द पार्टिकल विल कंटिन्यू टू बी एट rest. There is no force acting on this charged particle. Okay, now coming to the next case. What if the value of theta is equals to 90 degrees? If value of theta is 90, what is sine 90? Sine 90 equals to 1. And what will be the value of force? It is simply Q into V into B into 1. That is QBB. And this is the maximum force a charged particle can experience. So when does a charged particle experiences maximum force in a magnetic field? When the velocity of the charged particle is perpendicular to the direction of magnetic field. We can see in the adjacent diagram, there are some dots. What these dots represents? Dots represents the direction of magnetic field. And I have this charged particle which is moving in the magnetic field. Okay, just see. This is the velocity of charged particle. It is moving up. It is moving up like this. Okay, now how to find the direction of force? Direction of force you find out by, you can find out by the product rule of vector multiplication. Okay, first keeping the right hand in the direction of this velocity, and then closing your fingers towards direction of magnetic field. Where is the magnetic field? Magnetic field is dotted. That means it is coming outside. So this is my right hand. It is in the direction of velocity. And when I curl the finger outwards like this, and then I extend the thumb is going to show this direction. Okay, that means the direction of force is this. Now when velocity and force are perpendicular to each other, what will happen? The charged particle will move in circular motion. This we have studied in the concept of class 11. Whenever force is perpendicular to velocity, the particle moves in circular motion. Okay, now at this point where the velocity of a charged particle has changed, its direction has changed, again apply the rule for vector product to find the direction of force. You will have to keep your right hand in the direction of velocity. You can see my right hand is in the direction of velocity. And where is the magnetic field? Magnetic field is outside. So this is my right hand. I am now to turn my fingers towards direction of magnetic field. The thumb goes down. That means the direction of force at this point will be in the downward direction. This is the direction of force. And now what will happen? The charged particle will continue to move in circular motion. Okay, so I have just explained that when is the force minimum, when is the force maximum, and what is the effect of force. Okay, the effect of force is to move the charged particle in circular. Now coming to the final thing today, see, when this happens, that means if theta is equals to 90 degrees, then what is the force? Force is equals to B into Q into V, or Q into V into B. Okay, anyway. Now, what is this force doing? This force is moving the charged particle in circular path. If it is moving the charged particle in circular path, that means this becomes what? This becomes centripetal force. Okay, magnetic force becomes centripetal force. What is the equation of centripetal force? mv square by r. तो लॉरेंस फोर्स कितना है? BQV. किसका रोल प्ले कर रहा है? सेंट्रीपिटल फोर्स का. सेंट्रीपिटल फोर्स कितना होता है? mv square by r. Got it? So I can equate BQV, which is equals to mv square by r. And from here you can see one power of V cancels with one power, and r, this is BQ, which is mv upon r. Shift r to this side and BQ to this side. What you get is this. R is equals to mv upon BQ. M is mass, V is velocity, B is the magnetic field, and Q is the charge. Now what is M into V? Mass into velocity. Mass into velocity means momentum. Okay. So this is one way to calculate the radius of the charged particle. अभी आप बोलोगे सर ठीक है, लॉरेंस फोर्स ने पार्टिकल को सर्कल में घुमाया, ठीक है, उस पर सेंट्रीपिटल फोर्स लगाया, तो अगर वो सर्कुलर मोशन में घूमता है तो उसका रेडियस कितना होगा? How can you calculate radius? Radius you can calculate from this equation. R is equals to mv by bq or p upon bq. Okay. Now this particular thing, this particular topic of finding the radius, there are a lot of objective questions in examinations that will be asked. So you keep your concepts clear with this, and in the next lecture we will continue more about Lorentz force. Okay. Thank you for now.